try to be a little bit more positive spin. There are other feedbacks that may work the opposite way. You may have heard of this claw hypothesis, something I've done a fair bit of work on, which is a negative feedback. And let me just tell you how it goes. The idea is, as the climate warms up for some reason, some forcing, you get these plankton come to the rescue in the algae in the ocean. They emit more of this sulfur compound known as DMS, goes into the atmosphere, and that rapidly gets converted to particles and goes into clouds, and it actually can make brighter clouds, like these here, these stratocumulus over the ocean, right along our coast. So in principle, you could have a biosphere responding to climate change, pumping out a lot more of this gas, which then goes into making more reflective clouds or more expansive clouds, and thereby shielding the Earth from the sun. And so this was posited about 25 years ago and has yet to be shown to be actually active in the Earth that we live on. So it's a great idea. It's spurred a lot of research, but it has yet to show itself as being something we can definitely rely on as one of these negative feedbacks where, oh, well, the algae will save us. Okay, I was going to tell you something about California, but I'll just leave that for now. What I'd really like to point out, because this is about all the time I wanted to spend just unidirectionally talking to you, was that, when I think about this stuff, me personally, I think about what can we learn from the past, right? And there have been a whole host of environmental problems that we've encountered through scientific observation. And we've overcome them. It's not that big of a deal, actually. I mean, okay, it's a big deal, probably economically and so forth, but we've done this before, we can do it again. These are not insuperable problems. So, one of my favorite stories is that when the stratospheric ozone was discovered, this depletion that was happening in the stratosphere, people thought, we thought, well, we think it's the halogens, right? They won a Nobel Prize for that, Rowland and Molina, and so that was it. So we started halting the emissions of this, right? It took a while to get the political momentum going, but it stopped. And eventually DuPont probably smelled the spray paint writing on the wall and said, we better convert a lot of these chlorofluorocarbons to something that is less harmful to the stratosphere. So they did a lot of work in shifting that over. Turns out we didn't have the chemistry exactly right. Sure, it was halogens because they knew that, they pinpointed that, but they didn't know exactly how it was happening. They didn't know it was happening on these polar stratospheric clouds, these little crystals up high in the stratosphere. So again, we were wrong. Technically we were wrong, but we were righter than we were when we were pumping all kinds of these chlorofluorocarbons up into the atmosphere that make the stratosphere and destroy the ozone. So again, it's never perfect understanding. That's what makes it so much fun. But I just like to bring up these points to just give people hope that it's not something that we can't deal with. Probably. It may be, but it's probably not. And the physics underlying it go back a century plus, right? So it's not, what we're arguing about could be the details of how the system responds, and that's an important argument to have, but we pretty much know if we keep increasing these greenhouse gases in the atmosphere, it's hard to imagine a world where that's not going to go on. So those are the basic points I wanted to get across, and I have a bunch of other slides in case you want to bring up specifics. But that was all I really wanted to communicate to you first. So thanks for coming. Yeah.
I have one question. I only read the headlines, but there was an article recently on a different point of view between meteorologists and climate science. Are you aware of that?
I'm not.
Global warming?
No, I'm not aware of that at all. Those two fields to me are, well, I'm an atmospheric scientist, right? So I think climate science is built around that.
The impression I got was whoever did the actual short-term weather predictions had one view, and I thought they were suggesting that I think it was TV weather much longer.
Yeah, Brian Sussman, that's
TV weatherman. Okay. Well, no, that's cool. I mean, I went to school at Penn State, and there were a lot of people who I went to school with wound up on the Weather Channel all the time. Whenever I watched that channel, I'd say, hey, I know that person from the hall. So a lot of them are well trained. So I don't, but there's also a climate specialist on the Weather Channel who is specifically devotes her time to explaining things about it. So no, I'm not aware of any rift that's there, but Yeah.
Some of them particularly, they usually seem to be libertarians or skeptical of climate science or just climate science. And so one claim, for example, is that the heat goes up first and then the CO2 follows it.
All right, good. So that's true. When you scrutinize this is the reason I like this plot is it doesn't have the time part in it. But yeah, if you scrutinize these two time series of temperature and CO2 in the past, you'll notice that, yeah, the temperature changed and the CO2 responded after some lag of a few hundred years or something like that. And so here's the distinction. This is not to say that CO2 has been the sole climate driver in the past. That's not the argument. The argument is that these two things are linked. So the warmer it is, somehow more CO2 is coming out, and we understand the physics of that. You're going to get less dissolution in the ocean. There's very physical reasons why the CO2 would respond to that. But it's going to just warm it more. So it's part of this feedback that we're worried about. So what we're doing here, what we're doing is we're pushing the system into a region that we don't know what it's going to do, and we're doing it rapidly, and we're doing it in a way where we're not making the planet warmer. We're not just because of we're burning. It's not the combustion that's warming the Earth. It's the products that are shifting this into now a new stage. And so we're not saying that this has happened in this immediate past where the CO2 is forcing it, but we don't, but it should. Something's going to respond. It should respond. And CO2 is a very long lifetime in the atmosphere. So that's the difference. It's not saying that CO2 is always the driver and always has been, but it's intimately linked to temperature. Yeah.
As a climate person, I heard a long time ago that even if we solved all of resistance tension, we came up with fusion and so forth, eventually we wouldn't have a thermal pollution. We would bring out so much heat. But just simply,
could you speak up?
energy like that would cause a problem. Is that true?
Well, I haven't done that kind of thing. The question was that eventually, if the population keeps growing and we keep consuming energy at the rate we are, we're going to be liberating so much random thermal energy as heat, which you know as heat, that's going to be a problem. That's going to raise the temperature.
If we have a fusion reactor, we discover how to actually take advantage of fusion to make energy. So
Right.
it won't be having CO2 or anything. We'll still be
Right. There's still liberation of this. Well, at some scale that's true, and at some scale the sun's going to burn out and we're all going to die anyway. So it's going to keep you off target if you kind of focus on that. I don't really know the answer quantitatively to what the energy amount would have to be, but it's from my understanding the current energy use is nothing close to this, but we could do it afterwards on an envelope. So yeah.
Could you comment on the argument that CO2 is only, 0.03% of the atmosphere or something like that, and that
Composition-wise?
yeah, and that the additional anthropogenic part is only a very small percentage of that.
Well, it's not.
They
It's
make
about,
that argument also. And
so it's
how
about
do you
30 or
handle that?
40% of what it was 100 plus years ago.
Say it again.
The increase that we believe is due to our fossil fuel combustion is something like 30% greater than what it was. So it's not an insignificant change in the CO2 pool, right? It's like something like this. You're going from somewhere around here, high 200s, and you're now in the high 300s. So that's not an insignificant change in the CO2 part. We'll start with that. Does that make sense?
Partly.
This axis goes to 0, right? So this is what we know the natural variability of CO2 to be. This is what you might call a background, climate background of CO2. Well, we've now changed that by 100 of these units or more. So that's 100 out of 300. So that's 30%. We're changing that. It's a big change. It's not an insignificant change. And that's why I wanted to point out this Anthropocene. There's no way you can argue that humans are not moving, what I think of as moving elements around. We're not pushing chemistry around at an insignificant rate.